This is the video lesson for Geometry 4.1 Congruent Figures. In this lesson, we're going to recognize congruent figures and corresponding parts. So congruent polygons have congruent corresponding parts, and that means they're matching sides and angles. So when you name congruent polygons, you must list corresponding vertices in the same order. So you can see here, here's a polygon, A, B, C, D. And remember, when we name polygons, you name them in the order, the vertices need to be next to each other, so you can't do A, C, D, B, right? You have to, they go around. So A, B, C, D. So if you name this one A, B, C, D, you need to name, when you say that they're congruent, you need to list them in the same order. So you would need to, so see how A and E correspond based on the congruency of them? You would name this one E, F, G, H. So we would actually write that A, B, C, D is congruent to, and now A is congruent to E, so I'm going to write E first. B is congruent to F, so I'm going to write F, and then G and C, and then H and D. So this is specific to this one. This one can be any way, right? I mean, and not any way, they have to be next to each other. It could be DC, BA, or BA, DC. But once you decide that, then you have to match up the other one. And what that tells you too, like you can see in problem 1 here, they put the order, so you know that H is congruent to L. You can see here, right, A is congruent to E, and then also the sides, AB is going to be congruent to EF, and you can see that they're all listed. So this side's congruent to this side. We can actually do the, right, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4. Right, so and you can see, and then the angles are going to be congruent as well, right? These two, and then these two, and then these two, and those two. Okay, and just from knowing that these two polygons are congruent, you know all of this. Okay, so for the first problem, we're going to see it's going to, so it's going to show us two polygons, and it's telling us that HIJK is congruent to L, M, and O, and it's asking for the congruent corresponding parts. And we can get that, we don't even need the picture. And we can get that just from this piece here, right? So H is written first, so that's congruent to L. Angle H, we'll start with the angles. And then we can go through, right? Angle I, angle J, angle K, and that's, I is going to be congruent to the next, right, M. These are all angles. This is going to be M, and then N, and then O, right? So the order is going to be the same. And then the same with sides, but it's a little bit harder just because the picture helps, right? Since H is congruent to L, and K is congruent to O, and J is congruent to N, and I is congruent to M. Right, then the sides are going to be, so HI is going to, if right, red and yellow, red and yellow. And so we can write that HI, that side, is going to be congruent to LM. And if you look up here, right, HI is written first, LM is written first. So then you can do that too with IJ, MN. IJ, MN. And you can see here, IJ, green and yellow. MN, green and yellow. Okay, and then you can do that with JK and NO. And you can see here JK and NO. And then the last one's a little bit harder, right? You just have to take the last letter and the first letter. So KH and OL. So that's just the hardest one from these. KH and L. Okay, and those are corresponding parts. So since there are 4 sides and 4 angles, there are 4 angle pairs and 4 sides that are congruent. So those are our congruent corresponding parts. So try this one on your own. We don't actually have a picture for that one. But again, you don't need the picture. You can just go by the way that's ordered, and it's just a triangle. So see if you can name all, and here we have, it's a triangle, so all 3 angles that are congruent, 3 angle pairs, and all 3 side pairs. And then check back for your solution. Okay, hopefully you got this. W and M, Y and K, S and B angles, and WYMK side, YSKV side, and SWVM side. Okay, next page. We're going to do some algebra with this. So if we know that the angles are congruent, well, if we know the triangles are congruent, and we know which corresponding parts are congruent, then we know what angles are congruent. We can use algebra. Well, actually, we don't need algebra, but we can just name the actual measure. So in this case, we know that triangle ABC is congruent to triangle DEF, and we're asking for this angle here. What's angle D? Well, angle D corresponds to angle A. And angle A here is this angle. We don't know what that is yet, but we can see that there are 30 and 75, and these all three add up to 180. So we can take 180 minus 75, and then we get 105, and then minus 30, and then we get 170, just 75. So this has to be 75. So since angle A, measure of angle A equals 75, then we know angle A is congruent to angle D, right, from up here. So then measure of angle D has to equal 75. Okay, so try this next one on your own. There's no picture, but you can draw a picture. This is what you want to do here, right? There's triangle WYS, and then triangle MKV. Measure of angle W is 62, so draw a picture. Measure of angle Y is 35. And then see if you can figure out what measure of angle V is. So push pause, try it on your own, and then check back for the solution. Okay, and that equals 83. So if the measure of angle S equals 83, and S corresponds to V, then the measure of angle V, they're congruent, so this is also 83. First page here, right, where we had two angles in the triangle, right? Then we can figure out what the third one is. You always know what the third one is if you have two. Okay, now let's look at problem 3. Are the triangles congruent? Justify your answer. So we can now do this backwards, right? If we know that all three angles and all three sides are congruent, then the two triangles are congruent. So let's look at this here. We can see that B and C are congruent. So BC is congruent to DC. We can see here that since AC is 6 and EC are 6, AC is congruent to EC. So those are congruent. And then the other side of the triangle, they have the congruent markers. So that means AB is congruent to, and then A corresponds to E, so ED. So the three sides are congruent. Now are the angles congruent? Let's look. You can see these two angles are congruent. So angle A is congruent to angle E. Angle B has 2 marks, and so does angle D. So angle B is congruent to angle D. And then we know that these two angles are congruent because of vertical angle theorem. So angle, and we can't write angle C because, right, it would mean two different things. So angle BCA, that's this angle here, is congruent to angle DCE. So we have 3 sides of the triangle that are congruent and 3 angles. So then we can say, yes, the triangles are congruent. And we can actually write their congruent symbol, right? We can say, we know that A and E are congruent, B and D are congruent. So that means C and C. So we can say triangle ABC is congruent to triangle EDC. Isn't that fun? Okay, try this one on your own. It's a little bit harder. There's less information. So maybe they're not congruent. Try it on your own. So this is asking, is ABD congruent to CBD? So try this one on your own and check back for the answer. Okay, and just as I suspected, we don't actually have enough information to answer this question. So they could be congruent, right? Because AD is congruent to CD and BD is congruent to BD, right? Because it's the same line. But we don't know if AB and BC are congruent. They could be. we definitely know that we can't rule it out because we don't know anything about them. So since we don't have the third side, we can say that there's not enough information to decide if these two triangles are congruent. Okay, this last problem, not here on the theorem, is example here when we were trying to say, right, we saw in the picture that these two were congruent and these two were congruent. We actually didn't even need the vertical angle theorem here. We have the third angles theorem, right? Once you have two that are the same in a triangle, then you need a third. So we don't actually need three angles, we only need two. And basically what this chapter is going to be about is proving triangles to be congruent, and we're going to show as we go that we need less and less of these things. So we're starting with all six, like 3 sides and 3 angles. Now we're going down to 5. We just need 3 sides and 2 angles. And then we'll go down from there. Moving on, let's look at, we have a new theorem. So, and something that you may have noticed in here is pretty intuitive. But it is a theorem that we need to use, and it's called the third angles theorem. And so that says, if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are congruent, right? So if A is congruent to D and B is congruent to E, right? If you took whatever measure that is, it doesn't matter. And whatever measure that is, it doesn't matter. When you subtract it from 180, you get angle C. And since they're the same as these, then F has to be equal to C. So you only need 2 angles from a triangle. You don't actually need the third. So this is the first step in this. So third angles theorem says we just need 2 angles of 2 triangles to be congruent. Then we know the third one is. So if we can look at this problem 4, where we're going to start proving triangles are congruent with proofs. There are a lot of proofs in this chapter, but they're actually not too bad. And I think that you can feel better about proofs after doing this chapter. Okay, so in this picture, you can see LM is congruent to LO. So these two here. MN is congruent to ON. So these two here. Angles M and O are congruent. So here, and then angle MLN and angle OLN. So these two here are congruent. And we're going to prove that these 2 triangles are congruent. So LMN is this triangle here. We're going to prove that this triangle is congruent to LON, which is this triangle here. And so remember we need, we need 3 sides and 2 angles. So let's start with our givens, statements. So 1, we'll just write all of these. LM is congruent to LO. MN is congruent to ON. And these are, so we have 2 sides. And this is all given. And then we have congruent to O. And angle MLN is congruent to OLN. And here are our 2 angles. Okay, so we have our 2 angles. And in order, right, we actually do need 3 angles, but once we have the 2 from the picture, we figured out the 2, we can get the third from the third angle theorem. So that's what we're going to do here. We know that because we have these 2, that these 2 angles are going to be congruent by the third angle theorem. So our first statement after the givens are going to be that angle MNL is congruent to angle ONL. Okay, and the order does matter, right? So M matched up with O because they had the congruent angles. And then the N's are both the same, and then the L's are both the same. Okay, and we know this is true because of the third angle theorem. That's what it was called, right? Third angles theorem. Okay, so we have our 3 angles. Now we need 3 sides. We have 2 of them, so we need a third side. So let's look here. This is the third side we don't know anything about, but it's the same side. So we can say that LN is congruent to LN, right? And that's the reflexive property of congruence, which you'll learn to love, right? So that's a nice, easy one. And that's our third sides. So we have 3 sides. So we have our 2 here, This is the third. And then we have our two angles. This is the third. So we have three angles, three sides. And we can now say that the angle, triangle LMN is congruent to triangle LON. And we know this because congruent polygons, in this case we can say triangles, have corresponding congruent parts. All right, so here's one for you to try on your own. Push pause on the video and write out your proof. See if you can get this one. It's not too bad. There's just, if you look at it, there's just two things you have to add, I think. It's not bad. So please push pause, try this on your own, at least write the given on your own, and then check back for the solutions. Hopefully you got it. Okay, and then here's the solution. You can see from the given, we were given three sides, so we didn't even need to figure out any more sides, and one angle, so we needed two angles. But remember, with the third angles theorem, we have one of them, we just need the other one to get there. And in the picture, you can see that these two angles are congruent by vertical angle theorem. So once we have that angle, or that angle pair, then we know the other one, the other angle pair is congruent because of the third angles theorem. So we really just needed, once we had know that we need the third angles theorem, we really just needed one angle for this. And then we can say that the two triangles are congruent. And then this is what they were looking for. Sorry, on the earlier in the video, I kind of wrote the definition of congruent triangles. But the reason these two triangles are congruent is by the definition of congruent triangles, right? Because all sides and angles are congruent. And that's the lesson. Enjoy.